aerodynamics. Just a quick short video to answer a question sent to me by a student by a student in Miami, and an A&P airframe and power plant student. That student wants to know the difference between speed and velocity, because he's working. He has a group assignment that he's doing, and then they kind of some of the members of the group assignment tend to be confused with those two terms. Some of them think, okay, they're interchangeable. You can use speed and velocity. Okay, you can use either or. Is the same thing. That's what some of the students in the group, in the assignment group, think. Well, I'm here to tell you there's a difference between the two. First of all, there are two terms that are related to your question: scalar and vector. You may have scalar quantities. You may have vector quantities. So which of those two terms the speed belongs? Okay, well, scalar quantity. Speed is a scalar quantity. Scalar quantity. A scalar quantity only has one property, which is size or magnitude. But it does not have orientation. It does not have direction. That's a scalar quantity. So speed is a scalar quantity, because you may be driving your car 60 miles an hour. That's all you know. That's all I know. Okay. Oh, you're driving your car. You're driving your car at a speed of 60 miles per hour. But it doesn't tell you which direction you're going. Speed doesn't tell you that. It doesn't tell you you're going south. It doesn't tell you you're going north, east. It doesn't tell you that. It doesn't tell you. You're driving at a certain speed. But there's no direction mentioned. Okay? That's speed. That's a scalar quantity. On the other hand, a vector quantity has both size of magnitude and direction. a vector quantity, a vector quantity tells you your speed. It also tells you which direction you're going. Either you're going north, east, west, south, whatever. A vector quantity will tell you both, as opposed to a scalar quantity that tells you only one. So a scalar quantity is a number. You can add two numbers, 2 plus 2, and you got your result. Okay, 2 plus 2 equal 4. That's a scalar number, a scalar quantity plus a scalar quantity, and you get your result is a scalar quantity result. But vector quantities are more sophisticated than that. Vector quantities are represented by errors. Okay, you have errors when you talk vector. When you have a vector quantity, you have an error. Okay, the size of the error, that's the size of the quantity. If you have an error, that if an airplane is flying at a speed of 300 knots, so that arrow will the length of this arrow will represent 300 knots. 300 knots. If the same airplane reduces its speed to 200 knots, the arrow will be reduced as well. The length of the arrow will be reduced as well to match the speed of 200 knots. Okay, that's one property. That's one property of a vector quantity, which is represented by an arrow. Now the head of the arrow, okay, tells you which direction the airplane is going. Okay, the head of the arrow tells you which direction the airplane is going. So if you have a vector of 300 knots, okay, and the head of the arrow is heading the head of the arrow is heading east, for example, it means that the airplane is flying at a speed of 300 knots to the east. Okay, now, so as you can see, the vector quantity has both size, 300 knots, and direction, orientation, which is eastbound, So that's the main difference between just speed and velocity. So the vector, when you have a vector and then the speed at which the aircraft is flying, okay, represented by the vector, is measured in velocity. That means you have size and orientation. But the speed itself is just a number. Okay, now you're driving your car. You're driving your car at 40 miles an hour, but you don't know which way you're heading. That's just speed, a scalar quantity. I hope you understand the difference. And if your questions are always welcome. Your questions are always welcome, and if I have an answer, if I have answers, I will let you know. If I don't, I will let you know as well. So take care.